Hello boys and girls, it's Teacher Mike, and today we're going to be practicing with word problems. In this lesson, we're going to have to match a word problem to a picture to help us solve the problem. We're going to have to determine whether the word problem wants us to add or subtract, but don't worry, we have those addition and subtraction keywords that will help signal us whether we're going to have to add or subtract. Let's read the directions and get started right away, and I'll remind us of some of the great word problem skills that we've acquired over some of our previous lessons. Party problems. Read the word problem. Trace on the dotted line to connect each problem with the correct picture. Then check the correct answer to each problem. Let's read the first word problem carefully one time. Then we'll reread the word problem and underline the important information. We'll look for those addition and subtraction keywords as well. Dave made 3 flags, 8 stars, and 8 lanterns. How many decorations did Dave make all together? Okay, I heard the word all together at the end, so I think it's an addition problem. But let's reread the problem again and underline or pull out some of the important information and keywords. Dave made 3 flags, 8 stars, and 8 lanterns. How many decorations did Dave make all together? Okay, so we have that he made 3 flags, 8 stars, and 8 lanterns. We want to know how many he made all together. So we know he made 3 flags, 8 stars, and 8 lanterns. So let's find the picture first that matches this. Well, I can see right here there's 3 flags, so I'm already starting to think that this picture is the correct one. I know there's 8 stars, so let's count the stars. 1, 2, 3, 4, 5, 6, 7, 8. I also know there's 8 lanterns, so let's count the lanterns. 1, 2, 3, 4, 5, 6, 7, 8. So this must be the correct equation. So let's trace on the dotted line. The question asks, how many decorations did Dave make all together? So we're going to have to add 3 plus 8 plus 8 to find out how many decorations Dave made in total or all together. So we can add in any order that we want because the commutative property says so. So let's add the doubles fact of 8 plus 8. I know that 8 plus 8 is 16. That's one of my doubles facts. We can bring down what we have left over, which is 3 plus, which makes our new problem 3 plus 16. Let's count on 3 from 16. 16, 17, 18, 19. So 3 plus 16 is 19. So the total number of decorations that Dave made is 19. Let's read our next word problem and see if we can match it to a picture to help us solve it correctly. The second problem reads, Laura made 5 flags, 6 stars, and 3 lanterns. How many decorations did Laura make in all? Okay, let's reread this problem, and again we'll underline the important information and keywords. Laura made 5 flags, 6 stars, and 3 lanterns. How many decorations did Laura make in all? Okay, so I hear that keyword in all, so again, I think we're going to be adding everything up together to find out how many we have in all. I know she made 5 flags, 6 stars, and 3 lanterns. So let's look at the picture to see which one shows 5 flags, 6 stars, and 3 lanterns. Well, in this picture I see 1, 2, 3, 4, 5 flags, so I think that's correct. I also see 1, 2, 3, 4, 5, 6 stars, and 1, 2, 3 lanterns. So this must be correct. We can trace on the dotted line to this picture. Now, we have to figure out how many decorations she made in all. So we're going to have to add 5 plus 6 plus 3 to find out the total. Again, the commutative property says we can add in any order we want. So for me, I'd just like to add 5 plus 6 to get started. I know that another way to say 6 is 5 plus 1. So really the first thing I can do is just add 5 plus 5. And 5 plus 5 is 10. What I have left is plus 1, because I got that from 6, and then plus 3. I can easily add 1 plus 3. 1 plus 3 is 4. Again, I can bring down what I have left of 10 plus, and now I have 10 plus 4, and I can count up from 10, or count on from 10, 4 more. 10, 11, 12, 13, 14. So I know 10 plus 4 is 14, meaning that Laura made 14 decorations in total. Let's go ahead and check the correct answer. Remember, boys and girls, when you're solving word problems, having a picture to help really makes a lot of sense. So if you have the time, draw yourselves a picture that will not only help you get the correct answer, but will help you write an equation that matches the word problem, which you may need. Thanks for watching, boys and girls, and we'll see you next time. Hello, boys and girls. This is Teacher Mike, and today we're going to be practicing with word problems. The goal of today's lesson is to match the word problem to a picture. We do this so that when we solve word problems that don't have pictures, we can easily draw one for ourselves. Let's take a look at an example before we get started. Let's say we have a word problem that read, Sam has 7 chocolates, and Mike has 3 chocolates. How many chocolates do they have all together? Well, we want to find the total number of chocolates. If we had a picture, we could just count the number of chocolates. Well, we don't, so let's try to draw a picture for ourselves that matches the word problem. So we know that Sam has 7 chocolates. So let's draw 7 chocolates in the top row. 1, 2, 3, 4, 5, 6, 7. And we know Mike has 3 chocolates, so let's draw 3 chocolates on the bottom row. 1, 2, 3. Now it's really easy to find the total number of chocolates because we can just count the total number of chocolates. Let's count them all. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. There are 10 chocolates in total. This could also be written as 7 plus 3 equals 10. Let's read the directions for our worksheet and get started right away. Read the word problems. Which of the pictures matches the problem? Check the correct picture, then circle the answer to the problem. Let's read the first word problem. There are 7 oranges and 4 apples on a plate. How many pieces of fruit are there in all? Well, let's count how many oranges there are. We know we want 7 oranges. So let's see if the first picture has 7 oranges. 1, 2, 3, 4, 5, 6. So we know this can't be correct because the picture has 7 oranges. Let's make sure the second picture has 7 oranges. 1, 2, 3, 4, 5, 6, 7. Okay, that's good. But we also know there has to be 4 apples. So let's count and make sure there's 4 apples. 1, 2, 3, 4. Excellent. So this is the correct picture. Let's go ahead and check that. But now we want to know how many fruits are there in all. So we need to count the fruits in total. So let's count, starting with the apples on top. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. There are 11 fruits in total. We could have also written this as an addition problem. 7 for the oranges plus 4 for the apples equals 11 in total. Let's check out our next word problem. In this word problem, there were 15 flowers. Mary picked 5 flowers for her mom. How many flowers are left? So, but first let's find the picture that matches the word problem. Let's look at our first picture. We need to have a total of 15 flowers. So first let's count the first picture to see if there are 15 flowers. 1, 2, 3, 4, 5, 6, 7, 8, even though it's crossed out, it still counts. 9, 10, 11, 12, 13, 14, 15. Okay, there are 15 flowers in total in the first picture. But I also know that she picked 5 flowers for her mom. And when you pick something, that means you're taking it away from the bunch. So let's see if there are 5 flowers that are crossed out in this first picture. 1, 2, 3, 4, 5. There are 5 flowers that are crossed out. So this picture does match the word problem. Let's go ahead and check this picture. Now, we need to find how many flowers were left over. So we can count the flowers that are not crossed out. Let's go ahead and do that. There are 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10 flowers left that are not crossed out. Let's go ahead and circle 10. This could also be represented with a subtraction problem. 15 minus 5 equals 10. Remember, boys and girls, when you're trying to solve a word problem, draw yourselves a picture to help match the word problem to make solving it a lot easier for yourselves. You can check your work by solving it with an equation that matches your picture. Thanks for watching, boys and girls. We'll see you next time. Hello, boys and girls. It's Teacher Mike here. And today we're going to be looking at some missing number word problems. We're going to have to read the word problems very carefully, and we're going to have to use the strategy of counting on using a number line to help us solve these problems. What do I mean by counting on? Well, let's say we were trying to solve the problem 7 plus blank equals 10. How do we know what goes in the blank? Well, we can use a number line. Let's set up our number line from 1 to 10. If we started at 7, how many numbers would we have to count on to get till 10? Well, let's count together. 7, 8, 9, and 10. How many jumps is that? That's 1, 2, 3. So it took us 3 times, or adding 3 plus 7 to get to 10. So the missing number is 3. And that makes a good number sentence. 7 plus 3 equals 10. Let's use this counting on strategy to help us solve these word problems. Let's read the directions, get started right away. Solving problems with number lines. Read the problem, use the number line to count on and find the solution. Check the correct answer. Problem 1. Mary went on a 14-day trip to a summer camp. She has been at the summer camp for 8 days. How many more days is Mary going to stay at the summer camp? Okay, in this problem we know Mary has been at the summer camp for 8 days. We don't know how many more days she's going to stay at the summer camp, but we do know she has been there for a total of 14 days. Let's use our number line to help us count on and figure out how many days are left in Mary's trip. So we'll be counting from 8 up to 14. 8, 9, 10, 11, 12, 13, 14. Now, let's just count how many jumps that took us. 1, 2, 3, 4, 5, 6. So the answer, or the missing number, is 6. Go ahead and check the correct answer and write that in. We can add 8 plus 6 by counting up and see that the correct answer is 14. Let's take a look at our second example. Mike is playing a video game. He's got 13 points. He needs a total of 20 points to get to the next level. How many more points does Mike need? Again, we have the number sentence, 13 points that he already has, plus an unknown number of points to get to 20 points, or our answer, so that Mike can get to the next level. We can use our number line and count on starting at 13 all the way to 20, and we'll see how many numbers are in between 13 and 20, which will tell us the missing number. So let's count from 13 to 20. 13, 14, 15, 16, 17, 18, 19, and 20. How many jumps, or how many numbers, are in between 13 and 20? Let's count them one by one. 1, 2, 3, 4, 5, 6, and 7. And if we input 7 into our equation and added 13 plus 7, we would get 20. So that's a good number sentence. Let's go ahead and check the number 7 is our correct answer. Remember, boys and girls, even if you don't have a number line made, you can make one too. Start at the first number and count to the answer. the numbers that it takes you to get to the last number or your answer is the missing part in your equation. Thanks for watching, boys and girls, and we'll see you next time.
Hello, I am so excited to be with you today. What we have is a new worksheet that combines two of my favorite things. It combines reading with math, and these are called word problems. And we've got some tricky word problems for us today, but I know that you guys can do it because you are so smart. So let's get started. We've got tricky word problems part 1. And it says, read the number story and answer the questions. What we're going to do is we're going to read the number story 2 times. The first time we're going to read it to understand what the story is talking about. And then the second time we're going to read it to figure out what to do with the numbers in the story. Okay, are you ready? Here we go. There were 15 frogs in the grass. So it's a story about frogs. 5 frogs jumped into the water and 2 frogs hopped away. Okay, so that was the first time. Now we're going to read it and we're going to figure out what to do with the numbers. And I'm going to make notes to myself so that I can figure out what to do with the numbers in this story. So let's read it again. There were 15 frogs in the grass. So what I'm going to do is I'm actually going to come over here and I'm going to make a note to myself. There are 15 frogs and they start off, the frogs, in the grass. Okay, so here's 15, and there's 15 frogs. They're in the grass. Then it says 5 frogs jumped into the water. So we've got the number 15, and then 5 of them go away. So if they go away, we would subtract, right? So 5 of them jump into the water. Okay. And then it says, and 2 frogs hopped away. So then 2 of them go away. All right, so then it says, how many frogs left the grass in total? Now, the first time I read this, I thought it said left in the grass because my brain was trying to figure out what the whole problem meant. But don't be tricked on it. It says how many frogs left the grass in total. So if they left, they were the ones that went away. So we've got 5 of them that went away and 2 of them that went away from the grass. So what we need to do here is we need to add up those 2 numbers. So we've got 5 and 2. How many does that equal? Now over here, I put subtract because that means that they went away from the 15 total. But the question one more time says, how many frogs left the grass in total? The words in total lets us know that we need to add them up. So 5 plus 2, okay, is 5, 6, 7. So it's going to be 7. So let's find that equation over to the side. 5 plus 2 is 7. Let's see if we can find it. 5 plus 2 is 8. Nope, that's not the right answer. 5 minus 2, nope, we're trying to add in total. We're trying to add them, so that wouldn't be right. And then 2 plus 5 equals 7. 5 plus 2 and 2 plus 5 are the same thing, so that's actually the correct answer. So I'm going to put a check right here next to that equation, okay? Then the next one says, how many frogs stayed in the grass? Check 2 correct solutions. 2 correct solutions. So there's going to be 2 answers to this one, okay? So let's figure out what we need to do. We've got 15 minus 5 minus 2. That was originally going to give us the answer. 15 minus 5 minus 2. So let's see if we can find that over here. 15 minus 5 minus 2. Well, there it is, 15 minus 5 minus 2, and it says it equals 8. I think that that's correct, but let's go ahead and solve this problem so that we can figure out how much this is. So let's take 15, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And we're going to do just that. We're going to take away 5. So 1, 2, 3, 4, 5. And we're also going to take away 2. 1, 2. And that is going to give us the answer. And hopefully that's 8. So let's figure it out. 1, 2, 3, 4, 5, 6, 7, 8. That's correct. So 15 minus 5 minus 2 equals 8. So I'm going to put a check next to that one. But the direction said check two correct solutions. So let's see if we can find another solution. Now remember back to this first problem where we had 2 plus 5 equals 7. 7 can be written instead of 5 and 2. So let's see if we find a problem that says 15 minus 7, which is the same as this, 5 and 2, equals, and we know that the answer is going to be 8 total because it's the same thing whether we count 5 or 7. 1, 2, 3, 4, 5, 1, 2, or 1, 2, 3, 4, 5, 6, 7. It's the same thing, and it'll give us 8 both times. So 15 minus 7, let's see if we find that one. 15 minus 7 equals 8. There it is. That's our second solution to this problem. That was really tricky today, but you guys are such smart cookies. Great job today. I will see you guys again next time. Bye-bye.
Hello boys and girls, it's Teacher Mike here, and today we're going to be looking at some word problems. We're going to read the directions really carefully and read the word problems even more carefully. Let's get started right away. Birthday word problems. Read each word problem. Circle the correct operation, plus or minus, to complete the equation. Then add or subtract the numbers and circle the correct total. So in this worksheet, we're going to have to read the problems really carefully. Figure out whether the problem is asking us to add or subtract, and then solve the problem. Let's get started right away. Matt is really excited for his 7th birthday party. Matt is hanging balloons around. He has 5 blue balloons and 6 purple balloons. How many balloons does he have in total? Whenever I see a word problem, I like to read the whole thing first. Then I'm going to go back and reread the problem and underline the important information. Let's go back and reread and underline the important information. Matt is hanging balloons around. That's cool, but not so important for our problem. He has 5 blue balloons. That's some important information. Let's make sure to underline that. And 6 purple balloons. Another piece of important information that we should underline. How many balloons does he have in total? In total. There's my clue word. I think we're going to have to figure out how many blue balloons and purple balloons we have together. So let's draw my blue balloons. I know that there are 5 blue balloons. I also know that there are 6 purple balloons. So now that I have my drawing of my purple and blue balloons, I have to really think deeply. If I have 5 blue balloons and 6 purple balloons, and we want to know the total, do you think we're going to be putting these balloons together and adding them up, or taking some balloons away? In this problem, nowhere does it say that a kid popped a balloon or a kid took a balloon home. Nowhere the number of balloons is getting smaller. If anything, the number of balloons is going to get larger because we have to find the blue balloons and the purple balloons added together. We're going to be adding in this problem to find out the total. The word total usually gives you a clue that this is an addition problem. So let's count our balloons or add them together. I know we have 5 in the top row, 1, 2, 3, 4, 5, but let's keep counting to find out the total. 6, 7, 8, 9, 10, 11. Okay, I think there's 11 balloons, but let's just write 5 plus 6 and check one more time. Choose the strategy of counting on. 5, 6, 7, 8, 9, 10, 11. 5 plus 6 is 11, so this problem asks us to add the balloons, and it gives us a total of 11 balloons, both blue and purple. Let's read the next problem just as carefully and see if it wants us to add or subtract. At the very same birthday party, Matt and his friend ate pizza for dinner. There were 12 pizzas. The children ate 7 of them. How many pizzas were left over? Okay, good. We read the whole problem. But now let's back up and reread the problem and underline the important information. Of course, we'll draw the pizzas. Unfortunately, we can't eat the pizzas. Matt and his friends ate pizza for dinner. Sounds tasty, but not that important to our problem. There were 12 pizzas. That sounds like a fact. There were 12 pizzas there. Doesn't sound like we're getting any more pizzas, but let's keep reading. The children ate 7 of them. Another piece of important information. When you eat pizza, does the pizza disappear, or do you get an extra pizza? When I eat pizza, it usually disappears into my stomach. That's like taking pizza away, which is just like subtracting. But let's keep reading before we make that decision. How many pizzas were left over? So it seems like it wants to know how many pizzas were left after the kids ate 7. Now, if you ate 7, are we adding or subtracting? Well, let's draw our 12 pizzas. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 pizzas. Now, I ate 7 pizzas. Like I said before, those pizzas are disappearing, or we're taking them away, or we are subtracting those pizzas. So let's cross out the 7 pizzas that the kids ate to find out the answer. 1, 2, 3, 4, 5, 6, and 7. So how many pizzas are left over? 1, 2, 3, 4, 5 pizzas left over. So I think the answer is 5. 12 minus 7 equals 5. But let's write that, 12 minus 7, and use our strategy of counting back to see if 12 minus 7 really equals 5. 12, remember, don't count 12, 11, 10, 9, 8, 7. I have 5 fingers up. 12 minus 7 is 5. Boys and girls, remember, when you have a word problem and you have to figure out whether it's an addition or subtraction problem, look for clues like total or left over, and then draw pictures to help you imagine the problem and figure out the answer. Great job, boys and girls. We'll see you next time.
All right, so we have tick-tock word problems. Read the story problems below, tick the box next to the correct answer. So story problems or word problems lets us know that we have to read a story, but there's something that we have to do with the numbers to do something with math or the mathematical equation inside. So let's look at the first one. It says, the baseball game started at 2 o'clock. It lasted 2 hours and 30 minutes. What time was the game over? So let's come over here and let's write this out. We've got, it started at 2 o'clock, okay? And then it lasted 2 hours and 30 minutes. Now, sometimes we can set up a problem that has to do with math, I'm sorry, not math, but with time, just like we would a regular word problem. But sometimes we can't because minutes are not the same as other numbers because 60 minutes equals an hour. So it's a little bit different. But for this one, it says it lasted 2 hours and 30 minutes. So we can take 2 o'clock and we can add 2 hours onto 2 o'clock. So I'm going to add 2 hours. So we're going to look at just first the hour side, okay? We've got 2, and if it was 2 o'clock, it would be 3 o'clock, 4 o'clock. So 4 o'clock, and then it said 2 hours and 30 minutes, so I can actually add 30 over here, which will make it 4:30. That's the time. So let's come over here. We've got 2:30, 4:30. I'm going to put a check right here for 4:30, okay? Now let's do the next one. The next one says the first act of the circus started at 11 o'clock a.m. It was 1 hour and 30 minutes long. After a 30-minute break, the second act started. It finished 1 hour later. What time did the circus show finish? So let's set this up like we would a regular number problem, okay? So we've got 11 o'clock a.m. Okay, and I don't know if the AM is important or not, but I'm going to write it over to the side just in case, okay? And it said it was 1 hour and 30 minutes long. So if we were to add 1 hour to 11 o'clock, it would be 11 o'clock, 12 o'clock. So we would add this up, okay? 12 o'clock, and then it said it was 1 hour and 30 minutes long. So we're going to add 30 over here, and we've got 12:30, okay? And actually at 12 o'clock it becomes PM or the afternoon. And again, I don't know if that's important, but I'm going to write it off to the side just in case. It's always a good idea to keep those in mind just in case your answer tricks you at the bottom and wants to know, okay? So let's look at the next one. After a 30-minute break, the second act started. So we need to add 30 minutes because there was a break, okay? Now, when we add this up, 3 and 3 is 6, and 0 and 0, okay, is 60. Now, we don't say 1260. That's not a time. Any time that we've got 60 minutes, it equals 1 hour. So actually, I'm going to just put right over here 1 hour. We're going to add 1 hour on top of 12 o'clock. So 12 plus 1 would be 13, but there's no 13 o'clock. So when you think about a clock, okay, and we've got the time and we've got 12 o'clock right up here, what comes next? What's 1 hour later? Well, it would be 1 o'clock. So all of that's kind of confusing, but basically this equals an hour, 1, and then we're going to add 1 over here to the 12, which would be 1 o'clock, okay? All right, the next one says we've got a 30-minute break and then it finished 1 hour later. So if we add 1 hour to 1 o'clock, it's going to be 2 o'clock, okay? And that's going to be our correct answer. So we're going to come down here and we're going to find 2 o'clock. We've got 1 o'clock, 2:30, 1:30, and 2 o'clock. And that's actually 2 o'clock p.m. I didn't write that over here, but it wasn't really important. It didn't ask for a.m. or p.m., but it would be 2 o'clock p.m. So very good. That was really tricky. Adding up time is confusing because we can't add it the same way that we would add our regular math problems because there are 60 minutes in an hour, so that can be kind of confusing. But anytime you have 60 minutes, remember that it equals 1 hour, okay? Nice job, bye-bye. All right, today we have a new worksheet. The name of our worksheet is called Money Word Problems at the Pet Shop. And the directions say solve the word problems below. So we've got all these different animals here at the pet shop. And a word problem basically means that we have a little story that we're gonna have to read through, or a sentence or two, and we're gonna have to figure out what to do with the numbers in our story. So the first thing says, Mia has these coins in her purse. Which 2 toys could she buy for exactly the amount of money she has? Tick the correct pictures. So let's take a look. Mia has this amount of money in her purse. So let's figure out first how much that is. Mia has a nickel, which is 5 cents. And then she has another nickel right here, which is 5 cents. And then she has a penny. So we're going to add these up together. So 5 plus 5 is 10, plus 1 is 11. So Mia has 11 cents total. What we're going to need to do is we're going to find 2 toys that equals exactly 11 cents, or the amount that she has. And then it says tick the correct pictures. So let's take a look here. The first one, this little guinea pig, he is worth 3 cents, okay? The next one is the little tiger kitten, and he's worth 8 cents here. And then we've got the bunny. The bunny is worth 7 cents. And then the parrot is worth 10 cents, okay? So what we're gonna have to do is we're gonna have to find a combination of 2 of these, whichever 2 equals exactly 11 cents. So let's just start with our first pair right here and see if this works. 3 plus 8, okay? And what I'm gonna do is I'm actually going to I'm gonna add them over to the side here. I'm gonna take 1, 2, 3, I'm gonna draw a picture, and then 8. 1, 2, 3, 4, 5, 6, 7, 8. And then I'm going to take 8 and I'm going to count on 3. So 8, 9, 10, 11. Well, look at that. That one actually worked out perfectly. Those 2 are going to equal 11 cents when we add them up together, which is the total amount that she has. So what we're going to do is we're going to tick those 2 that equal 3 and 8. So 3 was my little guinea pig right here. And then 8 was the kitten. So the kitten is right over here, okay? Let's go down to the next one. The next one says, Sophia buys the parrot and the bunny. How much does she pay? Circle the correct answer. So the parrot is 10 cents, okay? And the bunny over here is worth 7 cents. So we're gonna add these up. So 7 plus 0 is 7, and then 1 plus nothing is 1. So that gives us a total of 17 cents. So we're gonna come right down here and circle the 17. The last one here says Noah buys the kitten. He pays with a dime. How much money does he have left? Circle the correct answer. So a dime is worth 10 cents. Okay, and I'm going to write that right here to remind me. But I need to take 10 and subtract it from the amount of the kitten. So the kitten is 8 cents over here, and I need to figure out how much that is. Now I can do it like this, or I could draw out a picture, and I think I want to do a picture. I like pictures, so let's do this. Let's draw 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Then I'm going to take away 8 since it's a subtracting problem. Please count with me as I count back 8. Here we go. 1, 2, 3, 4, 5, 6, 7, 8. And that gives me my answer. How many do I have left over? I have 2 left over. So 2 plus 8 equals 10. And 10 minus 8 equals 2. So I'm going to come over here and find my answer. 2 cents right here. Nice job today. Thanks for working that out with me.
And today we're going to be looking at some tricky time word problems. But with a good strategy, we can make these problems pretty easy and pretty fun. Let's read the directions and get started right away. Miss Rose's Sweet Bakery. Time word problems. Read the story problems below. Tick the box next to each correct answer. Now, I want to remind you with all word problems, we should read the problem once in its entirety, and then go back and reread the problem, underlining important information. So let's begin that way. Miss Rose owns a bakery. She opens her bakery at 9:30 every morning. The bakery stays open for 8 hours. What time does Miss Rose close her bakery? Okay, let's go back, reread and underline the important information. Miss Rose owns a bakery. Okay, that's cool, but we don't need to underline that information. She opens her bakery at 9:30 every morning. Now, whenever I see time or numbers, it's kind of a clue that that's going to be some important information. So let's go ahead and underline that. She opens her bakery at 9:30 every morning. The bakery stays open for 8 hours. I also think that's important. And finally, what time does Miss Rose close her bakery? So to me, this sounds like an elapsed time problem. We have the starting point. We know how long the bakery stays open, but we don't know at what time it closes. Let's use a timeline and see if we can figure it out. Let's start our timeline at 9:30, because that's what time Miss Rose opens her bakery. Now we're going to make small jumps. In order to work up to 8 hours of time, we're going to use friendly numbers to make this math easy for us. So whenever I see a 30, I always like to jump to an even hour. So I'm going to jump from 9:30 to 10 o'clock. Now when I jump from 9:30 to 10 o'clock, that's 30 minutes of time that have elapsed. So I'm going to write 30 minutes up top. Now from 10 a.m., I'm going to jump to 12 p.m. because I know that's only 2 hours, and I know that her bakery stays open for 8 hours, so I'm still safe. I'm already at 12 o'clock. The goal is that all of our numbers up top will be equal to 8 hours at the end, and we can find what time the bakery closes by seeing what time it is when 8 hours have passed. Let's keep jumping. Now from 12, I'm going to make a big jump. I'm going to make a 5-hour jump because I know that 5 plus 2 is only 7, and I've only used a half hour before that, so I'm still less than 8 hours. So let's jump from 12 to 5 p.m. Before we go any further, let's add this up. We have 5 hours plus 2 hours, and that's 7 hours. And I also have my extra 30 minutes, so I'll add 7 plus 30 minutes, and that gives us a total of 7 hours and 30 minutes. We're still missing a half hour of time, so let's jump another half hour. And if we jump 30 minutes from 5 o'clock, do you know what time we land at? That's right, we land at 5:30. So Miss Rose will close her bakery at 5:30 p.m. Using these small jumps, we really don't have to add very big numbers. Let's try this strategy for our next word problem. Miss Rose put her blueberry muffins in the oven at 8:15. She baked them for 25 minutes. What time were the muffins done? This time in our word problem, we still know what time she put. For this word problem, we still know what time she's starting at. She's starting at 8:15. But in this word problem, they tell us how big of a jump or how much time will pass. That's 25 minutes. And what we want to figure out is, what time will the muffins be done? So just like our other word problem, let's just add our starting time plus our elapsed time to figure out what time the muffins will be done. We can do this by simply just adding the minutes together. So let's add 25 plus 15. When I add 5 plus 5, I know that's 10. So I'll have to put a 0 in the ones place, carry a 1 to the tens place. If I add 2 plus 1, that's 3, and 3 plus 1, that's 4. And since we didn't add anything more than 60 minutes, we know our hour is still 8, so our time is 8:40. We can go ahead and check the box that says 8:40. Whenever you have an elapsed time word problem, use these small, simple, friendly jumps to help you make these problems seem a little bit smaller and a little bit easier. Nice job, boys and girls. We'll see you next time.
Subscribe to our channel to stay updated on new videos. Find links to our apps in the comments below.